And here's another math idea I did, I think around the same time in 2007 or 8. I don't know, but here's this like prime number thing I came up with, just kind of messing around on my calculator. And I have here Paul's prime number theory. Let P equal prime, starting with 2, 3, 5, and 7. Those are the first prime numbers, starting with 2. Well, I don't want to get into, actually prime numbers originally started with 1, but then the 1 was dropped. But anyway, the first prime number is 2. So we have 2, 3, 5, and 7, and other existing prime numbers after that. But the formula and numbers change as you continue plugging in prime numbers. And the individual function, or the formula for that is f of x equals 2, 3, and 5, and 7, or 2, 3, and 5, etc., 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 other prime numbers. The formula is p squared plus 3p plus 1 equals prime for 2, 3, 5, and 7. Actually, it's f of p equals p squared plus 3p plus 1. So p with the because it didn't have when I was using the Windows document at the time. It was called Word document at the time. It didn't have the where to put an exponent in that, at least that I could find. It didn't have a way to put an exponent, so I put the arrow, as I think I've also seen other people do before, and so here it is, p squared, f of p equals p squared plus 3p plus 1. So what you do is you substitute those numbers. You substitute p for 2, 3, 5, and 7 of those. So you take the p out and you place 2. So then f of 2 becomes 2 squared plus 3 times 2 plus 1 equals 4 plus 6 plus 1 gives you 11 prime. And then you just go to the next consecutive prime, which is f of 3, and that equals 3 squared plus 3 times 3 plus 1 equals 9, plus 9 plus 1, which gives you also another prime, 19. And then you go to 5, do the same thing, 5 squared plus 3 times 5 plus 1 equals 25 plus 15 plus 1 gives you 41 prime. And then you do the same thing for example 7, and that will give you 71 prime. So the formula changes as I found out it wasn't consistent. I haven't found anything that's consistent every time, but I basically came up with a way to use prime numbers to get other prime numbers. But the formula changes. So when you go to the next prime numbers, which are 11 and 13, it becomes p squared plus 3p plus 3. So then it becomes f of p equals p squared plus 3p plus 3. And that gives you a certain prime number. So you do f of 11 equals 11 squared plus 3 times 11 plus 3 equals 121 plus 33 plus 3 gives you 157 prime. And you go to 13, 13 squared plus 3 times 13 plus 3 gives you 169 plus 39 plus 3. I'm sorry, I'm in a weird mood. I had too much coffee. So 169 plus 39 plus 3 equals 211 prime. So then you go to 17 and 19, and those, the formula changes as well. One becomes a minus 3, another becomes a plus 3. So, and then it's just sort of, you have to kind of manipulate the formulas as you go along. And I went up to a certain point. When I originally wrote it on paper, before I printed it out, before I typed it out from my paper and then printed it out, I actually didn't have a printer at the time. I had to go to the library or to school or I had to I think when I was taking classes at ACC, I think I did go there once just to use their computer. That was shortly after I was taking classes there in years, but anyway, I think I did. But mostly I would go to the library or find available computer somewhere. For this one, it becomes f of 19 equals 19 squared plus 3 times 19 plus 3 equals 361 plus 57 plus 3 equals 421 prime. And then you do the next one, which is 23, and that becomes 23 squared plus 3 times 23 plus 3 gives you 529 plus 69 plus 2 gives you 601 prime. So there's other examples as you go along. So I wrote here, proven another way to use prime numbers and to equal other prime numbers by using a method are algorithms that get existing primes. In other words, you're just using a formula, plugging in prime numbers, consecutive prime numbers, to get other prime numbers by manipulating prime numbers as well as other numbers that are not prime in order to get other primes. Anyway, I gotta go. Peace. Bye.